Okay, so we're supposed to minimize surface area. So the surface area of a right cylinder, I'll use S for surface area. There's two surfaces on the top and the bottom, and they're circles. So we got pi r squared for the area of a circle. We need to multiply that by 2, and that gives us the areas of the top and the bottoms of the circle. And then we need to add the sides of the right cylinder. So that's the circumference of a circle. So that's 2 pi r, and then it's times the height. So if we're trying to minimize surface area, that means we want to take a derivative with respect to a variable. But the problem is we have two unknowns here. We have r and h. So we want to go back to the volume. The volume is equal to pi times r squared times h. And they tell us the volume is 54 pi. So one thing we can solve for in this formula is h really quickly. We can divide pi from both sides. So that gets rid of pi on both sides. We can divide r squared from both sides. So we're going to get 54 divided by r squared. That's h. So over here in the surface area formula, we can change it to be with respect to just one variable instead of two. H is 54 over r squared. So if we do some simplifying over there, we've got 54 times 2, that's 108 pi, and then we have just one r in the denominator, because r divided by r squared gives us r in the denominator. And so that's what you want to take a derivative. You want to take a derivative with respect to the radius in order to try to minimize the surface area. So taking the derivative with respect to the radius, this is going to be actually now subtract 108 times pi over r squared. I know it's hard to see with typing it out, but this is something we've seen a lot in this course. Taking a derivative of this term, it's 108 times pi times r to the negative first, if you will. So that's the derivative of that term. Set it equal to 0. And then if you want to solve for r, you want to multiply both sides by r squared to get it out of the denominator. It's going to be r to the third. So add that 108 to both sides. Divide that 4 from both sides. 27. Divide pi from both sides. If we cube root both sides, then the cube root of 27 is 3. That's pi to the cube root power, so that's 0.3 repeating. Does it want a decimal? You might have seen this one following along, but I dropped a pi up here. So you could divide each term in the equation here by pi to leave you with 0 equals 4 times r to the third minus 108. So there shouldn't be a pi here. So there shouldn't be a pi here. So I dropped that pi. This is just correcting for it. So that's cube root both sides. You get r equals 3. So the radius appears to be 3 for the minimized surface area. I mean, remember, this is a critical point. Set the derivative equal to 0 when we got 3 for a solution. That means r could be a min or it could be a max, so it's not guaranteed. But if you were to test r equals 2 and r equals 4, you'd see that this is a minimum. And so to find the corresponding height, you can just go over here, plug r in. So 54 divided by 27, which I think is 2. So 2 is the height for the radius is 3 and the height is 2. I guess it's a little late for me to be making this video. That's not supposed to be cubed, it's supposed to be squared. So it should be 9. So that should be 6 for the height.